Thank you, Sue Harrison. So now on UCT Urban Mine, understanding the local context to e-waste processing. Please welcome Thandazile.
Good afternoon, everybody. Okay, so I have about 10 minutes to talk to you about the UCT Urban Mine. Didn't feel enough to just leave it as the UCT Urban Mine, so I added understanding the local context to e-waste processing. So just as a pictorial background, how we are transitioning in the use of electronic devices in our day-to-day lives. That's shown in pictures. So just take a moment to think about what phone you were carrying in 1990 and look at what you have now and how many of those gadgets have passed through your hands in the last decade or more. So, right, so this is the consequence of your actions. So we use, we dispose, but what happens to what we have been disposing of? And how do we get the new ones that we have? So this is just a pictorial summary of our transgressions, if I may say so. So we have a lot of end-of-life electronic devices, not just limited to phones and computers, but think of all the white electronics you have at home. We transition through those at different paces in our day-to-day lives. And the end result in a linear economy is that we keep exploiting our natural resources, metals, and other, to make those gadgets and devices, then throw them into a dump somewhere. So I think Sue laid very good groundwork for the work that I'm presenting here, which was to say we're transitioning from a linear economy to a circular economy, where we're looking to use this end-of-life product or this waste stream as a resource. So what exactly is the composition of those gadgets that we carry in our day-to-day lives? In them we find plastics, and those are actually rated to have the highest theoretical recycling potential. And unfortunately, they are not just one category of plastics. There's separate types of plastic, different kinds of plastics in each gadget, and those have different recycling indexes, and some of them actually contain toxins. They are not just a plastic as you would imagine it. Some of them contain trace metals. So it's very important to actually understand what's in it and how we can then dispose of it. Of interest to us is the metals. These are actually the most economically attractive to recyclers, with an emphasis on printed circuit boards because of their high metal content, especially in terms of valuable metals, with special mention to copper and gold and some rare earth metals. In these gadgets, we also find ceramics, and because the traditional method of recycling has principally been to throw the end-of-life products into a blast furnace, you find that the presence of ceramics and glass has been criticized for resulting in poor recoveries in smelting processes. So further pictures, more pictures of the consequences of our actions and the industry that's growing from the waste we have been generating. Here you see a young boy who's trying to actually liberate some copper from plastic cabling. And the best way to do that is to use the plastic as a fuel, then get the copper out. So that's a young entrepreneur there, not aware of the risks they are exposing themselves to. So here are some gold-plated ceramic chips. This is what you would find being sent to smelting houses, and that's why there is the criticism of the ceramics in those chips with regards to how it affects the smelting process. So What is the South African context to this? Well, in South Africa, we're looking at reusing, reducing, and recycling activities in South Africa. At the moment, there is refurbishing, which basically is refurbishing and redistributing, where you're getting second-hand, you're giving a new lease of life to old electronic devices. You refurbish them, you redistribute them. We have quite a vibrant dismantling and sorting industry, which, well, it says it all. They dismantle, they sort, and they export. This is well linked to the size reduction and concentration. After dismantling and sorting, their size, the different fractions can be size reduced, concentrated, especially with regards to the precious metals, and exported. And we do have a bit of metal recovery processes. And unfortunately, we can be criticized to being cherry pickers in the sense that we're not looking to recycle all metals, but we're looking to recycle metals of high value. So broadly speaking, some of the challenges faced by the South African industry in terms of recycling of electronic waste is the fact that there is still a lot of groundwork that needs to be laid in this area. Our waste streams are mostly unaccounted for. So we still truly regard it as a waste stream because we all know how much work is being put in to actually quantify our geological ores. But this kind of an ore still is largely unaccounted for and unquantified, not just as an ore, but even in terms of when the refurbishing takes place. We don't have a good database with regards to that. And you find that disposal to landfills and dumps is still an option. You find that the public is still not well informed on disposal methods and risks of inappropriate disposal or haphazard recycling. If I were to ask how many of you keep old cell phones in their drawers right now with no hope of ever reusing them, I think half the room would raise their hands up. Let's just show by raise of hands. Where's that 3310 you had last 2 decades ago? That's a resource you're sitting on. So while that's true, the one other aspect is that even those that are actually in the recycling industry, there is actually still poor understanding of the value chains of this type of a resource. And last but not least in my points is the fact that the sector is still poorly legislated and poorly or inadequately monitored. Pardon my semantics there if there's any lawyers in the room, but the point is we need to do something towards the regulatory framework in this sector. So what is urban mining in essence? So it's been described as the process of reclaiming compounds and elements from products. So we're moving from traditional mining system. I'm hoping one day we will stop calling it traditional mining to call it geological mining, because traditional mining would essentially include urban mining. And urban mining leans towards a circular economy. Sue put up a picture on the circular economy and spoke to it prior to my talk, so I will skip through that. So just to juxtapose, we spoke of, I just mentioned traditional mining or geological mining, and I'm speaking about urban mining. Just a few thoughts that come to mind. How do we compare this geological mine setup to a tradition, to an urban mine? If you just look at how that stands and the task we're putting ahead of us when we're saying we're starting a UCT urban mine, how does that compare and what questions come to mind? So these are some of the questions that came to my mind. That is it actually possible to draw up such a diagram for an urban mine? How do we sample and measure the grade of an urban mine? We know, well, I'm not that sure of all the detailed process of a geological mine, but I know they speak of drill calls and sampling and all that before even the mine actually comes to life, to actually sort of exploration and all that. Where do we explore for an urban mine? Where do we even start with such? And how do we estimate the lifetime of an urban mine? We know we're progressing one day from another and changing gadgets from one to another, but the metal composition and the plastics in them is changing too. So how do we actually account for that variability when we're speaking of that as an ore? And what environmental regulations do we abide by? We know that in geological mining, a lot has been done towards developing a regulatory framework for such. And what environmental legacy are we going to leave behind? We've had many speakers this morning actually speak about the bitter taste that's been left in our mouths by the South African mining industry. If we're transitioning to this, if we're embracing this urban mining, what legacy are we going to leave behind? And the one other aspect is traditional mining is something that's actually profit-driven. Urban mining, on the other hand, we sit on either a waste or a resource. What is going to drive this industry? What business models are we going to follow? And what technologies support such processes? We have so many developed technologies. We know how to extract ores from sulfides and all the other difficult to process ores. But we're now looking at ores that are now an urban ore, which is probably coming from metals in their elemental state or alloy form, which technically thinking would be slightly simpler, but just how simple is it? And are there artisanal options, especially when we're now looking at the South African context? Are there artisanal options to this kind of urban mining? Can we say we have an artisanal mine? So those are the questions that come to mind and that I hope to answer, not alone. So what's the way forward for us? We have seen that we have a resource, but the one thing that I forgot to mention was that when you're looking at the urban mine, I spoke about what the mineralogy of that is. Do we look at it from a material-centric approach, which tends to be criticized for being one that promotes cherry picking? Or do we look at it from a product-centric approach where you have a product that you intend to recycle to the maximum possible? If you've had a conversation with Dee about recycling, she'll tell you about a team in Liège that has recycled a car, about 97% of a car. So are we looking to pick up a phone and say we've recycled it to 100%? Or are we looking to pick up a phone and say we've recycled the metals to 100%? Our approach is a material-centric approach. I feel guilty saying this because it sounds like I'm cherry-picking and looking for the value materials, but we have to put one foot forward at a time. But the one thing that I'm looking forward to see come out of this is to actually develop a flow sheet for metal recovery from medium and low-grade printed circuit board. Another step towards cherry-picking here, but in my defense, we are doing this already, and we need to be able to do this in a systematic manner and in a manner that will benefit our communities. And one of the things that we're hoping to see come out of this project is the fact that if not a process being developed, it's whereby we're able to inform policy and legislation in terms of what the disadvantages and what the governing parameters to such processes should be it in terms of characterizing the waste streams that come out of that and how their pollution potential or such parameters. And yeah, I think that just about sums all that I have to say. Thank you.